The National Electrical Code, or NEC, does not specify when and where to seismically secure light fixtures. However, the International Building Code, or IBC, does address this. IBC Section 1609.23, titled Seismic Restraint for Luminaires, states that luminaires shall be seismically restrained where subject to falling due to earthquake motion. Restraint method shall be designed in accordance with ASCE 7 and shall be approved by the building official. ASCE 7 is 16 Section 13.26, titled Luminaries, specifies that where the lowest point of the luminaire is 4 feet or more above the floor or platform, the luminaire shall be restrained to resist the forces in Table 13.2-1. Table 13.2-1 outlines luminaire seismic restraint forces. For luminaire attachment types, it lists horizontal and vertical force coefficients. For ceiling-mounted luminaires, the horizontal force coefficient is 0.5 and the vertical force coefficient is 0.2. For wall-mounted luminaires, the horizontal force coefficient is 0.4 and the vertical force coefficient is 0.2. For suspended luminaires, the horizontal force coefficient is 0.3 and the vertical force coefficient is 0.2. So, according to the IBC and ASCE 7, light fixtures that are 4 feet or more above the floor or platform and are subject to falling due to earthquake motion must be seismically restrained. The restraint methods must be designed in accordance with ASCE 7 and approved by the building official. In general, light fixtures that are suspended from a chain or cable should be seismically restrained. This is because the chain or cable can swing freely during an earthquake, causing the light fixture to fall. Light fixtures that are mounted directly to the ceiling or wall may not need to be seismically restrained, but it is always best to consult with a qualified engineer to make sure. In addition to the IBC and the ASCE 7, there may be other local building codes or ordinances that require light fixtures to be seismically restrained. It is important to check with the local building department to determine the specific requirements for your area. To reiterate, firstly, the NEC doesn't cover seismic requirements for light fixtures. Secondly, the IBC mandates seismic restraints for luminaires susceptible to falling during earthquakes. Thirdly, ASCE 7 provides the design standards for these restraints. Fourthly, luminaires 4 feet or more above the floor require restraint. Fifthly, different mounting types have different force coefficients: ceiling-mounted, wall-mounted, and suspended. Sixthly, suspended fixtures generally need restraint due to their swing potential. Seventhly, local building codes may have additional requirements, so consulting with the local building department is essential. When determining if a light fixture needs seismic bracing, consider the following factors. 1. The height of the fixture. If the lowest point of the luminaire is 4 feet or more above the floor, it generally requires seismic restraint per ASCE 7. 2. The mounting type. Suspended fixtures are more prone to swinging and falling, making seismic bracing crucial. Ceiling or wall-mounted fixtures might need it too, depending on local codes and engineering assessments. 3. Local building codes and ordinances. These may have specific seismic requirements for light fixtures beyond the IBC and ASCE 7. Always check with the local building department. 4. The potential for movement during an earthquake. Even if a fixture is less than 4 feet above the floor, consider whether it could swing and hit something, causing damage or injury. In such cases, seismic restraint is advisable. 5. Professional engineering consultation. When in doubt, consult with a qualified engineer to assess the seismic risk and determine the appropriate restraint methods. Remember that the horizontal and vertical force coefficients from ASCE 7 Table 13.2-1 are essential for calculating the forces the restraint system needs to withstand. Use these coefficients in your design calculations and ensure the design is approved by the building official. Let's further break down the application of ASCE 7 and IBC guidelines. We'll examine how to interpret the specifications for different types of light fixtures. Consider a scenario where you're installing lighting in a large warehouse. The fixtures are suspended by chains from the ceiling, placing them 6 feet above the floor. According to ASCE 7, since the lowest point of the luminaire is more than 4 feet above the floor, seismic restraint is required. The horizontal force coefficient for suspended luminaires is 0.3 and the vertical force coefficient is 0.2. These coefficients would be used to calculate the seismic forces acting on the fixture and its supports. The restraint system, including cables, chains, and anchors, must be designed to withstand these forces. Now, let's say you're installing wall-mounted sconces in an office building. The sconces are 5 feet above the floor. Again, since the height exceeds 4 feet, seismic restraint is necessary. The horizontal force coefficient for wall-mounted luminaires is 0.4 and the vertical force coefficient is 0.2. The mounting hardware and wall anchors must be sufficient to resist these forces. For recessed lighting installed directly into a suspended ceiling grid, the seismic requirements might be different. If the ceiling grid itself is seismically braced, the recessed fixtures may not need individual restraints. However, it's important to verify this with a qualified engineer in the local building department. They will assess the ceiling grid's capacity to withstand seismic forces and determine if additional restraint is needed for the light fixtures. It's important to understand the approval process. The IBC requires that the restraint methods be approved by the building official. This means you need to submit your design calculations and specifications for review. The building official will ensure that the design complies with ASCE 7 and any local amendments to the building code. Always document your design and installation thoroughly. This includes providing detailed drawings, calculations, and product specifications for the restraint system. This documentation will be essential for obtaining approval from the building official and for future inspections. Now let's discuss some practical methods for seismically restraining light fixtures. For suspended fixtures, you can use safety cables attached to the fixture in the building structure. These cables should be strong enough to support the weight of the fixture and resist the calculated seismic forces. The cable should be installed at an angle to prevent the fixture from swinging excessively during an earthquake. For wall-mounted fixtures, use heavy-duty anchors that are designed to withstand shear and tension forces. The anchors should be installed according to the manufacturer's instructions, and the wall itself must be strong enough to support the fixture and the seismic loads. For recessed fixtures in suspended ceilings, ensure that the ceiling grid is properly braced and that the fixtures are securely attached to the grid. Use clips or fasteners that are specifically designed for this purpose. These clips should prevent the fixtures from falling out of the ceiling grid during an earthquake. It is important to consider the interaction between the lighting system and other building components. For example, if the light fixtures are located near sprinkler heads, make sure that the seismic restraint system does not interfere with the operation of the sprinklers. Similarly, if the light fixtures are located near HVAC ducts, ensure that the restraint system does not obstruct airflow or damage the ducts. Keep in mind that seismic design is a complex field, and it's always best to consult with a qualified engineer who has experience in this area. An engineer can help you assess the seismic risk, select the appropriate restraint methods, and ensure that the design complies with all applicable codes and standards. Furthermore, ongoing maintenance and inspection are vital. Regularly inspect the seismic restraint system to ensure that it is in good condition. Check for loose connections, corroded hardware, and damaged cables or anchors. Replace any damaged components immediately. After an earthquake, it's essential to inspect the lighting system for damage. Look for cracked fixtures, broken supports, and displaced components. Repair or replace any damaged items as soon as possible. Now, let's address some common misconceptions about seismic restraint for light fixtures. One common misconception is that only large, heavy fixtures need to be seismically restrained. In reality, even small, lightweight fixtures can pose a hazard if they fall during an earthquake. Another misconception is that seismic restraint is only necessary in areas with high seismic activity. While it's true that areas with high seismic activity have a greater risk, earthquakes can occur in many parts of the world. Therefore, it's always a good idea to follow seismic design principles, even in areas with low seismic activity. A third misconception is that seismic restraint is too expensive. While it's true that seismic restraint adds to the initial cost of the lighting system, it can save you money in the long run by preventing damage and injuries during an earthquake. Furthermore, the cost of seismic restraint is often a small fraction of the overall cost of the building. Let's look at some examples of specific products used for seismic restraint. There are many different types of seismic restraint products available on the market, including safety cables, wire rope isolators, and seismic braces. Safety cables are typically made of galvanized steel or stainless steel and are designed to support the weight of the fixture and resist seismic forces. Wire rope isolators are used to isolate the fixture from the building structure, reducing the amount of vibration and stress that is transmitted to the fixture. Seismic braces are used to provide lateral support to the fixture, preventing it from swaying excessively during an earthquake. When selecting seismic restraint products, it's important to choose products that are designed for the specific application and that have been tested and certified to meet industry standards. The product should be easy to install and maintain, and they should be compatible with the other components of the lighting system. Now let's delve into the legal and liability aspects of seismic design. Building owners and contractors have a legal responsibility to ensure that their buildings are safe for occupants. This includes complying with all applicable building codes and standards, including those related to seismic design. If a building fails to meet these requirements and someone is injured or property is damaged during an earthquake, the building owner and contractor could be held liable. Therefore, it's important to take seismic design seriously and to work with qualified professionals who can ensure that the building is safe. In conclusion, seismic restraint for light fixtures is an important aspect of building safety. By following the guidelines in the IBC in ASCE 7 and by consulting with a qualified engineer, you can ensure that your light fixtures are properly restrained and that your building is safe for occupants. Remember to check local building codes, consider the height and mounting of fixtures, and maintain thorough documentation of your design and installation. Ignoring these precautions could result in property damage, injury, or even loss of life during a seismic event.